Hi, everybody. Thank you so much for joining us today for our special webinar series on JuliaSim. And today we're going to address a pretty important topic, in the context of JuliaSim itself, and in the context of JuliaSim itself, and which is to do with the import and export of functional mockup units. This is sort of really important when you're thinking about, say, how do you do some kinds of work within JuliaSim and export your work to another modeling platform, or say import some modeling, import some models from a different modeling platform into JuliaSim and get started. My label here says JuliaHub, but my name is Ranjan. I'm a sales engineer here at JuliaHub, and I will be your host and presenter today. So for those of you who aren't familiar with what Julia itself is, Julia is an open source programming language which we believe solves something called the two culture problem. So we find that there are lots of folks who that end up being in one of these two silos at an organization. So there are engineers who build physics-based models of, say, equipment, and then there are software engineers who try to design the firmware that goes, the embedded software that goes onto this equipment. Whereas the engineers, of course, are building the physical, trying to simulate the physics of the equipment itself. And we find that this work happens in two different silos, and Julia itself, as a programming language, is meant to bridge these two silos. Specifically, Julia is a scripting-like language that feels a lot like writing Python, but has the performance of something like C, C++, which allows you to write embedded software within Julia, but at the same time is fast enough to also support things like building physics-based models. And so this is what Julia itself is. In case you're new today and this is the first webinar that you might be attending. This webinar itself is just one in a series of webinars that we have. So we initially started off with introducing what JuliaSim, the product itself, looks like. And then you're essentially talking about things like system simulation and so on, and how these models both have a graphical as well as a code-based representation, sort of one-to-one in some sense. Then we went through things like building control systems, designing these control systems within JuliaSim, and then we spoke about how you could generate code for embedded devices using JuliaSim, and we showed a little example of building a binary that goes onto an ARMv8 system. So today, what we're going to do is talk about functional mockup units. This is what we would call, say, our model deployment side of our product. So most of the webinar series and in some sense has covered all of the various verticals that we support through our product, including development, refinement, analysis, and deployment. With functional mockup units, we're going to comment a little bit on deployment. So I want to talk about three things today. I think this should be a fairly quick session. With us. It's mostly a how-to on how exactly you would do these things within JuliaSim. I mean, these are definitely supported, like most other simulation tools support deploying to functional mockup units. But we're going to cover a couple of things: how exactly you might import a functional mockup unit within JuliaSim. I'm going to quickly touch on this FMI.jl package, which is open source. And then, I'll get to something a bit more interesting with regard to how to work with these models within JuliaSim. And then finally, we'll comment on how you export, how you go from designing the models on the graphical side to exporting these models, as FMUs, to be imported into other environments. So the functional, the functional mockup interface is a very widely used standard for exchanging dynamical models. If you're not familiar with what it is, it's supported by hundreds of tools as shown here. Lots of tools. Most of the tools that you're probably using in your everyday already support the functional mockup interface, which makes it really, really powerful as an open standard. You can go through the way, different tools offer different levels of support. Of course, that's how it goes. So if you go to the website on the slide here, you'll be able to tell which tool offers which features, either in terms of import, export, and so on, and if there are any qualifications to using the interface within those tools. But within JuliaSim, we both import as well as export functional mockup units. And we'll talk a little bit about workflows involving this feature. But I just want to quickly show you the tool and the product. The first thing is that I wanted to show you is importing these functional mockup units. So let me head to my little script here. So this to recall, this is actually a code editing environment, so every model that you build within JuliaSim, and this is what JuliaSim, the graphical interface, looks like, is backed up by a GitHub repository. So in this particular case, this GitHub repository is also backed to github.com, but it could, of course, be backed by a number of different Git backends. And you see that this model has associated with it a Git repository, with a source and a test, like any Julia package that you might be familiar with. And specifically in the context of JuliaSim, we have this GSML folder, which has a bunch of models that are written down within JuliaSim. And these GSML files that you can see over here will be represented graphically in our environment, but backed up textually within a Git repository, which makes reproducibility and so on pretty useful within JuliaSim. And you can see the same code is accessible from here as well. All right. So once you've built the model within JuliaSim, we currently don't have a button from this particular interface to export an FMU, although that's part of our roadmap. Let us know if you're interested in something like that. I'm sure you would be. But what we actually do is at least today, is you can actually connect to this. You can connect to this or interact with this repository through a code-based interface, which is what I'm doing here. And this is where this is coming from. The first thing I actually want to show you is importing an FMU. So in this particular script, I am importing the FMI package. So the FMI package is an open source package that you can pick up and use within Julia, completely free. Maintained by Tobias Tummerer and a bunch of our collaborators. It's really powerful and really nice. It has good documentation on how to use it as well, and good examples. And I would highly encourage you to check out this entire documentation here. And so this will give you a number of steps on how to import these FMUs. So you'll see things like, the basic command here is called load FMU, which would given a path, which will just load the FMU for you, and you'll get some information on the FMU as output, as given by this page here. So you'll see you'll see a bunch of different examples in this repository, and I would highly recommend you try them out. But what I wanted to comment on here is not this exactly, but something a bit more interesting. So, from the perspective of building these realistic models, what I'm going to show you here is how you could couple, you could import an FMU and couple that with a modeling toolkit or JuliaSim model that we develop in this system. So here I have a very simple adder model here, which has 5 variables, one input and a couple of outputs. So what I'm going to try and do is to couple these outputs together. So you'll see that if I had two of these Adam models, I could couple, I could send the output of one model could be fed as an input to the other model, and vice versa. So this is what I mean by couple simulation of these models, right? So initially, what I'm going to do is show you how this works with just two simple JuliaSim models, and you can see that of course we're providing some initial conditions here, but we can go ahead and simulate the system and and you can see we get a few answers. Um, Now with an FMU, you can load FMU just like you would with the FMI.gl construct, and you can take a look at you can of course look at the you can look at the FMU itself and interact with it. Uh, you know, Perhaps look at the model description and so on. It'll tell you which version of FMI and so on. It is the which standard the FMU has been which version of the standard the FMU has been exported with, and the interesting thing I wanted to show you today is this feature within Modeling Toolkit called FMI component. So what this is going to do is import that FMU as a modeling toolkit model, which makes it super, super nice. So if you can see my little terminal here, if I did add a one, you get this nice little representation at the command line for the modeling toolkit model, but I get essentially the same type of representation for the FMI model or the FMU, within modeling toolkit as well. So you can see that this is a nice interface to work with this model. And similarly, I can do things like I can figure out what the inputs of the model are, and you can see the FMI for example, we can simulate, or we can call modeling toolkit.inputs on the FMI function and see the and look at the input ports. We can call outputs as well and look at the output ports. So you get nice little conveniences like this, and you can interact with it just like you would any other JuliaSim model. And the nice little cake is you can also in the icing on the cake is you can also interact with modeling toolkit models, much like you would with general JuliaSim. Sorry, you could interact with these FMI models, much like you would with general JuliaSim models, um, by just specifying these equations as we've done in the previous case, i.e. treating it just like any other JuliaSim model, and then you can simulate them, and it should just simulate. So this is sort of the most this is sort of new within our ecosystem here. It's quite powerful in terms of what we're doing now with functional mockup units on the import side. Um, and I thought I could let you know about this. So maybe I can pause for a quick second and see if there are any questions. Don't be shy. Feel free to interrupt me anytime. So you could think of workflows, like, for example, you would have a plant model, say, written in one tool, and you would have a controller written in another tool, and you can export maybe the plant model as a functional mockup unit, do the and then do the control design within JuliaSim, and that's a workflow that this would support. And what's nice about it is that the FMU, you can work with the FMU interactively. You can obviously work with the controller interactively, and you can couple both of those in a manner that's intuitive. Okay, so the next thing I wanted to show you was the syntax on how you would export an FMU model. So we have a tool internally called FMU generation. So what this is going to do is help you export FMUs, and this sort of script just shows you how exactly you can do that. So what I'm going to do is import a particular model here, and I'm just going to then the syntax for exporting an FMU from JuliaSim is just calling this function JuliaFMU exported by FMU generation.jl. This is not open source. This is part of JuliaSim, and it will be available in our general availability version coming this summer. So you should be able to open this, do exactly what I'm doing here. Just open it up in this code environment, and then call JuliaFMU on your modeling toolkit model, give it which version of the FMI standard you want to export with, and either model exchange or co-simulation here. And this is fairly straightforward. If, for example, there are input and output ports within your modeling toolkit model, you can just already specify them within JuliaSim itself, and it should just pick it up. You don't need to specify any of those things manually, and you should just be able to do this internally. Of course, since we know everything about the inputs and outputs of the system and parameters of the system, we should be able to infer all of that and just build the FMU for you. It should be fairly straightforward. We can also do this with surrogates. So the surrogates are simple causal components. Just like, of course, FMUs are causalized as well, but these surrogates are simple causal components. So these few lines of code are essentially how you would take this active suspension model, build a surrogate model with the active suspension here. So what this is doing here is specifying some standard parameters. In this particular case, I'm just specifying the gain values of the PID controller. To recall exactly what that is, this model consists of a few mass spring dampers along with a PID controller in here, and this PID controller has gains that are specified at the top level. So you'll see the gains somewhere around here. So what I'm doing is essentially trying to build a surrogate that tries to take this coupled system and understand how the system performance is across a number of different gains for this PID controller. And so the way you would do that is again specify an upper and lower bound of these parameters, building this Cartesian space, and call the parameter space object on this along with a number of samples that you want to build a surrogate with, and then calling simulator configuration on your model will give you this object, which is essentially a data set that is used to train the surrogate, and then you can call digital echo on it. I'm not running this code right now live because it's going to take some time to train, but this is exactly how you would do it, and at the end of it, you will get a surrogate model, which is a simple causalized modeling toolkit component itself. And the way to deploy that surrogate model as an FMU is just calling this function called deploy FMU. And again, it knows everything about the system, so it should just be able to deploy that as an FMU for you. So you can take this and do interesting things like say you had a particular plant model in another simulation that says is a little bit slow, so you want to build a surrogate model of that. You could bring that in as an FMU within JuliaSim, or you could maybe build a plant model within JuliaSim, build a surrogate of that plant model, right, and then export that surrogate model to be integrated into the other modeling tool. So this is exactly how you'd export an FMU. So to recall, there are two ways. You can, of course, just directly work with modeling toolkit models and just call this function JuliaSim JuliaFMU on the model, and it should just export an FMU for you. The reason I'm not running this is it currently will generate a Julia system image and incorporate all of the modeling code within that. So this will also take a little time to generate an FMU. So that's something to keep in mind. But of course, it'll just do it, and you don't need to worry about it. Just takes a few minutes, but this is sort of the clean syntax that I don't believe we've exposed to our audiences before. So this is what you do to export an FMU of a JuliaSim model, and this is what you do to export a JuliaSim FMU of a surrogate model. Um, so those are the two pieces I wanted to show you guys. Any questions on either of these? Okay. If not, so these two workflows, the two workflows that I wanted to talk to you guys or explain through is to go through is maybe one option is you could start off with, or you could build your model in JuliaSim, perform all the real world calibration, or use JuliaSim as a way to essentially use JuliaSim as a way to build plant models, right? Fast plant models, simple plant models that you can then export and then use for control design in another tool, right? So that's a very plausible workflow that is supported with this tool. You can, of course, if you had a plant model that's already implemented in another tool and you just wanted to make that faster, you can bring the FMU into JuliaSim and then build a surrogate model of that FMU and then export that surrogate model back as an FMU. So you get a slow FMU, you put back a faster FMU and then you use that for the design. And if you wanted to do a workflow like this, we actually have some documentation on our website for you to check out. Um, you can use the FMI package, as I said, wonderful FMI, a wonderful package there for importing FMUs in Julia, and you can use the same surrogates interface just like this, like I just showed you with these labels. Labels, of course, indicating the exact the variable names of the variable names within the FMU or the parameter names within the FMU. And you can set up a simulator configuration like shown, and you can start running this and get a you can run this as a JuliaHub job, of course, like if this is going to take a long time to run. But you can just call simulator config if you just wanted to run the single threaded and get the result and essentially get the data set here, and then finally you can build a digital echo of this, and you can see here that we have oops, let's look at the final result here. You can see here that the prediction here is line over line. So this is just a simple example of how you might do this with this workflow here. I do see a couple of questions, so I'm just going to pause and take them. Are you able to run these FMU standalone? Yes, you can run these FMU standalone. You don't need a copy of JuliaSim on the machine that you're running these FMUs. It's pretty straightforward. At least as of right now, we're not, we have there's no cost as such, either in terms of having JuliaSim installed on the machine you're running these FMUs or any of those things. How large? The second question I have is how large will these FMUs be? Right now, they're going to be on the order of 100 megabytes. Why are they so large? They're compiling almost the entirety of JuliaSim or Julia rather, right? Like into and all of these libraries into a system image, and the system image is essentially shipped as a library within the FMU package itself or the FMU artifact, right? What we are doing something about that. We have a whole new stream of development within Julia that's called JuliaC, It's with the latest Julia 1.12, which is still not released. But Julia C will let you compile these FMUs into very small executables. So if you recall the previous webinar, we actually compiled a binary down to a Raspberry Pi or an ARM V8 system, right? And we did a software in the loop simulation within JuliaHub itself on x86. Both those binaries were on the order of 2 or 3 MB, which is pretty good. Much smaller than we have today, like an order of magnitude at least reduction in the file sizes. Those were both done with Julia C. Now, Julia C will become the standard way in how we compile and ship these FMUs. Specifically, Julia C does a few smart things to get rid of most of the Julia runtime so that it can give you as small a library as possible. So that's going to be the new way we're going to export FMUs. That of course is a work in progress. Again, it's on the latest Julia that's not quite released yet. So we are expecting to incorporate that and get those FMUs down to 2 or 3 MB. Anyway, that's a long-winded answer to say that today it's 100 MB, tomorrow it's going to be 2 or 3 MB. Okay. Next question, and let's go here. What about cross compilation? Great question. Now, so remember how I told you that you can run all of these things as JuliaHub jobs. So for example, if you look at the surrogates here, they have a whole interface to run this through JuliaHub. Why is that important or interesting? So what this will do currently is, there's just two answers to that, right? So firstly, supposing you're on a Linux machine and you want to compile something to Windows. Let's say you're on Windows and you want to compile something for Linux. Through this JuliaHub job interface, we can actually, let's see if this is able to load. But really, like through this node type interface here, you can take this code, this code, put it in a script, and then tell JuliaHub to launch the script on a Windows machine. So what that will do is it will compile this on the Windows machine, and you'll get a Windows FMU as an artifact that is then associated with the job. Then you can click download and download the Windows FMU. So that's one possibility, right? Like if you're on a Windows machine, you're using JuliaHub, you can get the Windows FMU that way. That's already supported and is part of our product, and you can access that at the first JuliaSim publicly available release, right? Now, the next question is, let's say I'm on x86, but I want to compile to ARM, right? You can, currently we're built upon AWS. You can use something like a Graviton instance. Not necessarily today, that's something that's upcoming as part of our product offering, is that you can take a Graviton instance and do the same workflow, right? Take this code, throw it in a script, and tell JuliaHub to run this on a Graviton instance, and then you get an ARM v7, ARM v8 FMU compatible FMU artifact. Download that, copy it over to the ARM device. You're good, right? So while Julia itself does not do this cross compilation, through our product, we are able to perform this cross compilation through leveraging these different images, cloud images. I hope that answers the question. Okay, few more questions. So one question on FMI v3. We do support FMI v3. We can compile to FMI v3. We can import FMI v3 as well. Of course, I believe FMI.jl also does support FMI v3. I'm pretty sure they had an example here, but part of course the constraint to showing these examples is that you need, I guess, only some of the commercial tools support FMI v3 properly. Some of the open Modelica tools or the free Modelica tools that don't yet have comprehensive support for FMI just yet, FMI v3 just yet. That is ongoing, but we in general support FMI v3. I think that's a fair statement to say. And of course, if you have questions, we can deal with that. Source code FMU. I don't think we support source code FMUs just yet. It shouldn't be a problem. It's not hard for us to do that. We just don't do it. We just don't do it as of the moment. But really, it's just a flag, right? Like we can bundle the script used to generate the FMU, or bundle the model code used to generate the FMU. That shouldn't be a problem. But we just don't do that today. Uh, Another question. Do we support both co-simulation model exchange? Yes, we do. We import, you can import both as co-simulation model exchange. You can export both as co-simulation model exchange, even both as co-simulation model exchange as well. That's all supported. There are some edge cases here and there for, certain models can only be exported as co-simulation and so on. Let us know what kinds of models you want FMUs of, and we can help you deal with that. But yes, in general, we support both. All right. Are there any other questions? This is basically what I wanted to show you. I can maybe talk to you a little bit about the entire workflow. Again, so maybe, in case it's not clear, so I actually have this is the simplest JuliaSim model that I can possibly implement, right? Like it's just a one level inheritance of our standard example, called active suspension. And if you want to know what the active suspension model is, you can go to our documentation. We have this example components library. You can click on active suspension and look at its parameters and behavior, and all of the equations are given, in our public documentation. But the simplest thing I'm doing is just simply extends from this example components, and this is the simplest JuliaSim model that will generate a bunch of Julia code. So this, you can see all of this is modeling toolkit code. So JuliaSim is automatically generating this Julia code here, and I am compiling this Julia code over here when I call this library called FMI test, right? It's called FMI test, and I can grab this and interact with this within Julia interactively. And as another perk, you can say export this as an FMU, which is what I showed you how to do today. So any other questions? Can we import an FMU using the graphical interface and connect it to other components? Not right now. You should be able to you should be able to do that in the future. It's on our roadmap. It's not hard. You really what we would do is, as you can see here, when we say import FMU, uh, right, as an FMI component, you get a modeling toolkit model. What will happen within JuliaSim is when we import an FMU, you'll get a bunch of JSML code generated, and when you have JSML code generated, you can visualize that in the graphical interface. So fairly straightforward. We're working on it. It's not hard. The pieces are there, but it will be. We hope it should be in the first version that we release, but we'll see. But yes, that's definitely the idea, to be able to import it into this interface and connect it just like you would. Any other questions? If there are workflows that folks have that involve, using a bit of JuliaSim, using another tool, any combinations of different tools, please do reach out to us. I will actually, maybe I haven't, I'll give you my email over here. I forgot to do this in advance, but here you go. So my email is ranjan.anantharaman@juliahub.com. We have, of course, our general, our sales email as well, where you can contact us. And of course, you can go to juliahub.com and reach out to sales from there. if you have any technical questions on what we discussed today, please feel free to email me, and we can have a conversation. One more question. Can you use JuliaSim FMUs in a software in the loop setting? Yes, you should be able to. I think, of course, we should look at your specific model, and please do email us if you have a particular model in mind, or if you'd like a little demo. But my first answer is, in general, yes. We were able to demonstrate a software in the loop simulation with other Julia components in a previous webinar. So I would recommend you to check those out. And we treat these FMUs as general modeling toolkit or JuliaSim components anyway, so we should be able to support that. But again, if there is a specific test you had in mind, please reach out to us, and we'll take a look for you. Any other questions? If not, I just wanted to thank everyone for joining us today. This was quick fire, but it was fun. So, and if there's any questions or comments on anything that we discussed today or on any of these previous webinars, these webinars should be on our website, by the way, especially these ones. And of course, this will also be on our website. So please feel free to check them out, and let us know if you have any specific problems you want us to take a look at. And otherwise, thank you for your time today, and I will close it here. Thanks, everyone.